sklearn, features election, select percentile. Description. Select percentile is a feature selection method in scikit-learn sklearn that ranks features based on a scoring function and selects the top percentile of features. This method is useful for reducing the dimensionality of data by keeping only the most relevant features. Inputs. sklearnf, a function that takes two arguments, the training data x and the target labels y, and returns a score for each feature. This function defines the criteria for feature ranking. Common scoring functions include fclassif and over f-value for classification tasks. This measures the variance between class means divided by the variance within classes. Mutual info classif, mutual information for classification tasks. This quantifies the dependency between features and the target variable. chi2chi² statistic for classification tasks. This assesses the independence between categorical features and the target variable. Regression and over f-value for regression tasks. This measures the variance between group means divided by the variance within groups. Mutual infogression, mutual information for regression tasks. This quantifies the dependency between features and the target variable. Percentile, the percentile of features to select. For example, if percentile 50, then the top 50 of features based on the scores will be selected. Outputs. Transformed data, the transformed dataset with only the selected features. This output will have a reduced number of columns compared to the original data. Selected features, a list or array of indices representing the features that were selected. Steps. Scoring, the sklearnf is applied to the input data x and target labels y, generating a score for each feature. Ranking, the features are ranked based on their scores. The top features based on the percentile value are selected. Transformation, the input data x is transformed by keeping only the selected features. Metrics. Feature importance scores, the scores generated by the sklearnf provide a measure of feature importance. Model performance, the performance of a machine learning model trained on the transformed data can be used to assess the effectiveness of feature selection. Visualization plots. Feature importance plots, a bar chart or histogram can visualize the importance scores of features. This can help identify the most important features for the prediction task. Scatter plots. Scatter plots can visualize the relationship between the selected features and target variable. Fine-tune parameters. Sklearnf choosing the appropriate scoring function is crucial for effective feature selection. The choice of scoring function depends on the type of task classification, regression and the nature of the features. Percentile, the percentile value determines how many features are selected. A higher percentile selects more features, potentially leading to better performance but also higher dimensionality. Uncertainty methods. Cross-validation, using cross-validation to evaluate the model's performance with different feature subsets can help estimate the robustness of the selected features. Challenges and fixes. Challenge 1: choosing the correct scoring function for the specific task and data. Sample use case: using the fclassif scoring function for a regression task. Fixes: using the appropriate scoring function based on the type of task, e.g., regression for regression or exploring different scoring functions. Challenge 2: setting the percentile parameter appropriately to balance feature selection and model performance. Sample use case: selecting a very low percentile, leading to the exclusion of potentially important features. Fixes: experimenting with different percentile values through cross-validation to find a balance between feature selection and model performance.